This is not a guide for using weak links. Using a weak link is potentially dangerous and should only be done by qualified personnel operating in conformity with all applicable federal, state, and local laws and regulations.
All right, we're going to talk about weak links. So these are the little devices that we use on the bottom of the wire. We call it a weak link because you can make it weak by the selection of what bolt you use or what pin you use, and we're going to get into that. And the idea behind the weak links is you know that you can pull 20,000 pounds, 21,000, 16,000 pounds on your 3x19 torque stabilized 9/16 control wire. You don't want to exceed the working load limit. You don't want to exceed the yield strength. You especially don't want to go over the yield strength, 24,000 pounds, regardless of what waiver you got. So you would put a bolt here that would break before you get at that. But you wouldn't put this bolt at a 24,000 pound rating because there's also the weight of wire in the water column, which this weak link won't see because this weak link is down on the seabed at your dredge. And you also don't want to lose a dredge, so you'll rig it up in such a way that you have a main weak link with a big bolt or a big pin and a smaller weak link with a smaller bolt or a smaller pin. So you can see these are different size holes here, 5/16 and 3/8. If you're in really deep water, you've got a lot of weight of wire and 1.4 pounds per meter. So at the bottom of a 5,000 meter dredge, you're really maxing out. Your weak link might be an aluminum bolt, or it might be a silicon bronze bolt. If you're working up at the surface in a 1,000 meter dredge and you have a lot of overhead, you might use a titanium bolt. Although titanium is a bad, fussy metal. It's a great metal, but it's kind of fussy. It has a high degree of variation in what it breaks at. This bolt will break anywhere from 11,000 pounds to 14,000 pounds. This bolt breaks at about 4,700 pounds. This is a silicon bronze bolt. This bolt is an aluminum bolt. It breaks about 2,000 pounds. After about that, I mean, if you're sending a dredge to the bottom and you're using a 2,000 pound bolt on the side of your dredge bag, that means your main weak link is probably, if this is 2,000 pounds, your main weak link is probably 4,500 pounds or 5,000 pounds. You're not getting much less than that. Dan Fornari wants to break rocks off at 18,000 pounds. So if you're using an aluminum bolt, you're kind of, it's not really, now at that point we need to talk about using synthetic tension member to go down there. The old style was using bolts and putting bolts through it. And the really old style, here's a really old weak link, and you see it's riddled full of holes, all kinds of holes. And some people would believe that you could put all these different bolts in. You could put an aluminum one, and a silicon bronze one, and a steel one, and you could put them all in here and add up all your numbers. But they don't shear all at the same time and in all the same fashion. So the fleet, by and large, we're moving away from this. If you talk to professional riggers in other industries like timber and lumber and whatnot, absolutely not one bolt. One of the other issues that might be why this is still a bunch of dogma in the fleet is the nature of this type of shear in engineering terms. This is called double shear because there's two shear planes. There's a shear plane right here and a shear plane right here. So there's a double shear plane, one shear plane and another shear plane. Single shear would just be, that would be like a single shear. But since we're using these in a double shear, which is the best way to go, you have the word double in there, which kind of means, you know, some people interpret that double holes. So this is double shear. This is not an approved shear. So we're going to just push that out of the old picture, and we're not going to go there anymore. We're going to standardize with this. This is something Dan Fornari has been trying to get the fleet to standardize forever, and we're now moving in that direction. We're also moving out of using bolts, and we're moving into using pins. And there's a good reason for that, because you can have one standard size diameter, and then you can machine it down. So this one, we've removed metal in exactly the plane where the shear loads are going to happen. And what's nice about that is, if all of this stuff falls on the floor, you can pull it all out. You can get this, you can mic it, and you go, oh, that one is that one from that bag. It's good for that value. if you have a bunch of shear bolts in a container like this, which is really nice and easy and organized, and it seems really good, and this falls on the floor, they all fall out on deck. Now you don't know what values are in, which brings us to Exhibit A. None of these we can use anymore because we don't really know which ones they are. The box broke and shattered, and they all fell on the floor, and everything's all mixed up. So all the time that was taken putting all these little labels on here, this is great, but it's maybe not the safest way to carry your bolts around. This is really cool, but they all look almost exactly the same. And if these all fall out, then we're done. We're done using them with any degree of confidence. Back to the pin idea. And we've got brass and aluminum. There's some plastic one if you just want to do something in the lab to show somebody. And same, you can have a 3/8 inch pin or a 5/6 inch pin. The reason aluminum's here, that might be kind of eyebrow raising, but there's a lot higher tightness on breaking of aluminum. You might break 3 or 4 of them, and the differential that they break at is in maybe 100-pound chunks. The differential that these break at is in a couple 1,000-pound chunks. So the aluminum is really tight. So that means if you put a bolt in here that's going to break, you want to break at 4,000 pounds, your aluminum might be plus or minus a couple 100 pounds of that. If you put this bolt in there, it might be plus or minus 2,000 pounds of it, which you might exceed the yield strength of the wire. So we're kind of moving into the direction of these pins, and they'll probably end up, if aluminum is the way we're going to go, we're going to probably end up with shear for this is all for deep water work. If you're doing this at the only a couple 1,000 meters or 1,000 meters, a couple 100 meters deep, and you want to use all the strength in the wire, and we'll have another weak link. We don't have it here now with a 1/2 inch hole in it and a 1/2 inch pin of aluminum, so you still have the ability to scale up. And the other nice thing is you can just bring 1 wad of material on board, and you can make them as you go. You just turn it down on the lathe. It's pretty simple to do. It's kind of the same idea if you've seen our hydrostatic wire cutter video of the brass pins that go in there and you drill a hole out the center of the brass pin. This is just a little bit easier to shave off material. So that's how that works. These fit together. One thing when you're fitting them together and putting them on the dredge, you'll want to save this piece. If you do lose the dredge, you'd rather lose this piece. So attach this piece towards the ship and attach this piece towards the dredge. Then you can make up these a lot faster and easier. And then the shear thing, it wants to be a complete guillotine type event. So you don't want to have it, number one, if you're using bolts, you don't want to cramp down on the bolt and tighten it and tighten it and tighten it up, because that's a sort of a compression fit as well. You don't want that to happen. You just want to use a nylock nut and spin it down tight. These guys, they're pretty tight, and you kind of got to pound them in there a little bit. And then a little clip on the end. Put your little circlip on. And then I go ahead and I wrap the whole thing in tape as well. And that. Almost there. Get some old cruddy duct tape that doesn't work for anything else. And what's actually nice about using the duct tape, when this comes back, if this is all mangled and covered in dirt, you'll get to see, like, is it dirty? Is it muddy? Was it scratched up? Did you actually get to the bottom, or were you just like towing through some weird who knows what? And when this all comes aboard, you can look at the cable as well. You want to actually see shiny spots on the cable. The chafe on the cable from the seabed is good. It means you're fishing hard on the bottom. That's what you want. You're going to cut that cable off at the end of the cruise. This little bolt is an old one. It's used. You only want to use these pins, one for each drag. That kind of preserves your value. You know you didn't score it accidentally. If you're running low on them for any reason whatsoever, you can get by using it again. If you pulled on it close to the strength that you thought it was going to break, by all means, you have to punch it out. You definitely want to punch them all out at the end of the cruise. You can see one of these was left in, and we're banging on this bolt and banging on this bolt and banging on this bolt, and it's broken off. It's still in there. We got to get it. We got to drill it out. So that's kind of an older one, and I like to have a couple of these as demonstrations. This was a bolt we pulled 16,000 pounds on it. This is a brand new bolt. This one's 4,700 pounds. Aluminum one, I said 2,200 pounds. And then these, we're just going to refer to the chart for the amount of material that was removed. Brass, aluminum. The plastic's more just a test bed. Here's our little chart from the bolts. When you go through the bolts, you have to send them off to a lab, and you buy a bunch of bolts, and you don't know what you're buying, so you're going to order some stainless this and stainless that and some aluminum this and bronze that. You got to order it, you got to buy it, you got to have it come all back, and then you send it off to the lab, and then the lab breaks a bunch and gives you this thing. And all that takes time, and you're stuck there a couple days before the cruise. You just got the stuff back from the lab, and at that point, maybe a week before the cruise, oh crap, none of our values worked out to be what we needed. So we thought we were planning for this cruise, but now all our time spent planning didn't really get us anywhere forward. So by going to this little method, you can tailor in. You got 3 different bolt sizes, 5/16, 3/8, half-inch bolt size, and multiple different materials. One thing with the pandemic, the steel quality control has gone off the charts. Steel's gone through the map, so we moved out of using steel and moved into different metals that had a tighter tolerance when we tested them. We've got all these charts on the MARSSAM website you can look at, and if you're setting up for a cruise, just talk to us and we'll help you with this. And we'll tailor and do a little run of these for exactly the depths that you need. So that's how the weak links work here. We can run out on deck and show you how to rig them on the dredge.